with the last two functions we are going to look at this class: exponential and logarithmic. Logarithmic, yes, functions. The last two functions we are going to look at in this chapter, in this course. Now, the reason they are together is because they are inverses of each other. So the exponential is the inverse of log. Log is the exponential of the inverse of exponential. Okay, so we're going to start with 4.1, which deals with exponential. I hope you have the book open. I do have it on the multimedia library. I have it open on that device, not on one that you see what I write, that I am connected with you. So please, if you'd like to open Exponential Functions Chapter 4, and because I will ask you to choose some problems from there, or I will choose problems from there. So, okay, exponential function. I never said I would say that, but it has a tremendous application in real life situation, and it's exactly what we are going through these days. It's a very, very fast growth function, the fastest we've ever seen. And it's about the pandemic that I'm going to talk about in a minute, but let's decide first of all what is an exponential function. An exponential function is a function that has the variable that is the exponent. This is a number. So a is a constant. That a is called the base. Is the base. X is the exponent, also called power if you want, and that is the variable of the function. That is the independent variable. We do have some restrictions here. For example, can I raise 1 to the 4th power? Yes. Can I raise 0 to the 3rd power? Yes. Can I raise -2 to the 3rd power? Yes. However, these bases are not allowed in the exponential function. So the base can be a number greater than 1, not 1. Also, the base can be a number that is positive but tiny, between 0 and 1. The base cannot be 0, cannot be 1, cannot be -2. All these exist, but they're not allowed in the exponential function as the base. And the obvious question is why? If I can raise 1 to whatever power I want and 0 and negative numbers, why I cannot have them in the exponential function? And here's the main reason. This function will not exist. Okay? So the logarithmic function is the inverse of the exponential. If we allow the base to be 1, 0, or negative, this function will disappear. So that's why we have to restrict the base. This constant cannot be 0, 1, or a negative number. Okay, so since, like with everything, right, the linear function can look like this or like this. The quadratic function can look like this or like this. Same thing with the exponential. It has two shapes. One shape when the base is greater than 1, a different shape when the base is less than 1. So expect two options. So let's look at the first option with f of x with the base greater than 1. Let's say 2 to the x. The domain of this function is everything. This is a nice, friendly function. We want to graph it. We want to look at it, see how it looks. I'm going to punch in some small numbers like -2, -1, 0, 1, and 2, and graph. But I need to determine these ordered pairs. Okay. Can anyone tell us how much is f of -2? In other words, I'm asking 2 raised to negative 2. How much is that? 2 raised to negative 2. Anything raised to a negative power is 1 over 2 to the second power. It's 1 over 4. So this is 1 over 4. Can anyone give us 2 to negative 1?
Over 2.
Excellent. Can anyone give us 2 to raise to 0?
0.
Careful.
1.
Yes. Yes. Any number raised to 0 is 1, except 0 raised to 0, which is not 1. And when I plug in 1, 2 to the first power is 2, and 2 to the second power is
4.
Very good. Now remember the end behavior. Let's go this way first. 1 over 4, 1 over 2, 1, 2, 4, 8, 16, 32, 64, 128. Where am I going? What do you think? A wild guess. It's okay if you're wrong.
Infinitely.
Thank you. Now let's go this way. 1, 1 over 2. Now imagine that I have a pi and I divide it by 4 people. Then I have a pi and I divide it by 8. Then I have the same pi and I divide it by 16. And then I divide it by 32. And then I divide it by 64 people. And then I divide it by 128 people. And then I divide it by 10,000 people. How much will you get?
I mean, you would still just get a fraction. You'd never actually reach 0.
Very good. Which means y equals 0 is a horizontal asymptote at negative infinity only. Excellent. That is perfect. Okay, we are ready to graph. We've never seen anything like this before. A horizontal asymptote only one side and blows up, we say, to the other. Okay? -2, -1, 1, 2, so on and so forth. So at -2, it's tiny, 1/4. At -1 is a little bit bigger, 1/2. At 0 is 1. At 1 is 2. At 2 is 4. Look at this. The fastest growth. This is the function 2 to the x. And this is what we are going through these days. A person gets infected, and then the next day 2, and the next day 4, and the next day blah and blah. So when they say we want to flatten the curve, this is what we want to do. Hopefully this. But right now it's going this way. It's terrible. That's why one day we have 10 people, and then the next day 150 people, and then the next day 2,000 people. It's the fastest possible growth. That's our tragedy now. We are trying to do this. Staying away from each other, blah, 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 all that. We are trying hard. It's not working as of yet. Okay. I never thought I would be so afraid of this function ever before. Okay, so this function has a lot of characteristics. First of all, it's defined everywhere. So let's list them. So properties. So we understand what this means. So first of all, domain, all real numbers. Can anyone give us the range of this function? I'm talking about pure exponential function, no transformations. If we throw in transformations, it's going to be a different story, but still the domain will be the same. So can anyone give us the range of this function?
Would it be 0 to infinity?
Excellent. Next, y equals 0 horizontal asymptote at negative infinity. Is this function increasing or decreasing on all its domain?
Increasing.
Yeah, unfortunately. Increasing on all its domain. Is it 1-to-1? By the horizontal line test. Is it 1-to-1?
Yes.
Yes. Does it have an inverse function? By definition, if it's 1-to-1, we will always have these always go together. If it's 1-to-1, you will have an inverse function. Okay. Can you give me a couple of points so I can graph the inverse function that I don't even know anything about yet? I'm coming back to my table. Please give me a couple of points, 3 points, so I can graph the inverse. Anyone?
-1, 1, and 2.
Careful. This is x, this is y for the inverse. This point is reflected. This point is reflected, right? So we have 1, 0. We have 2, 1. 2, 1. We have -1, 1/2 -1. And so on and so forth. My graph is not perfectly symmetric to the line. My apologies. So when I fold a graph with respect to this line, they have to overlap. My graph is not perfect. Good, so this is the inverse function. That's how we get points for the inverse function, right? If the function has -2 1/4, the inverse will have 1/4 -2. If the function has 0, 1, the inverse will have 1, 0. They are all reflected with respect to y equals x. And as you see, if the function is increasing, so is its inverse. Now, for the inverse function, since I have it right here, remember the two are reversed. The domain of the function will be 0 to infinity as you see it, from 0 to infinity, and the range will be negative infinity, infinity, from negative infinity to positive infinity. Okay, let's look at the other shape. Let's say f of x equals 1/2 raised to x. Let's take a look at that. Still domain all real numbers. Any exponential function has domain all real numbers. I'm going to use the same values, -2, -1, 0, 1, and 2, and let's determine these numbers so I can graph it. So let's plug in -2 here. So 1/2 raised to -2, flip the fraction to power 2, 4. 1/2 to -1, flip the fraction to power 1, 2. When I plug in 0, I have 1. When I plug in 1, I have 1/2. When I plug in 2, remember 1/2 squared is 1/2 times 1/2, which is 1/4, or 1 squared, 2 squared. Okay, so now let's go this way and then this way. So determine the end behavior. 4, 2, 1, 1/2, 1/4, 1/8, 1/16, 1/32, 1/64, 1/128, 1/10,000. Where am I going?
0.
Thank you. Y equals 0 horizontal asymptote at infinity only. This way. 1, 2, 4, 8, 16, 32, 64, 128.
You're going to infinity.
Excellent. So here it is. I plot the points. -2, 4. -1, 2. 0, 1, 1, 1/2, blah, blah, blah. It gets more difficult to plot. Here it is. Do not touch the horizontal asymptote. So this is the graph of 1/2 to the x. And this is an exponential function with base less than 1/2, less than 1, between 0 and 1. Everything is the same except this. And the horizontal asymptote, which is at positive infinity this time. So everything the same, it's just that the function is decreasing on all its domain, and y equals 0, horizontal asymptote at infinity. The domain is still the same, the range is still the same, it's just that it's a decreasing function. Is it 1 to 1? Yes. Does it have an inverse? Yes. Can I graph the inverse? Yes. Do I know anything about it? Yes. No, not yet. Good. So give me a couple of points so I can plot the inverse.
4, 2,
4,
1.
4 comma negative 2. So 4 comma negative 2. This point where the function crosses y equals x has to be part of the inverse function as well. So this point 1 comma 0 has to be there because I have to cross the x-axis, and that's more than enough. Here it is. And this is the inverse function. If the function decreases, as you see, the inverse decreases as well. Okay, so let's look at a couple of problems. I'm hoping you are looking at the multimedia library. And I'll tell you the page number if I find my keyboard. I started with 464, but I want probably 475. Oh, it's a different keyboard. Sorry. It's a different computer. Sorry. Where is it? Okay. So 475. Let's see. 475. Okay. Yes, perfect. That's what it is. 475. I would like us to I don't see any transformations here. I need to look at a transformation. So let's take a look at a transformation. So f of x, let's say, it's negative 2 raised to x plus 1 and plus 4.